Acumenor presents billet and collet holder start to finish. This is the stock we're going to use. It's from a project long ago. I used to do fire testing, and this is left over from samples. They're 6" by 6" by 1". I did the model in Fusion 360, and I didn't think anybody would have the patience to watch me model this. But I'm doing the tool runs in Fusion 360, and this is the process that I do the tool runs. So I switch over to cam, and I'm going to pick the boring tool. Now before I do that, I have to go in and pick the work coordinate system. So that picks the origin, which is going to be at the top of the material, lower left hand corner. And then another thing I have to do is make sure I pick the units, because it defaults to millimeters and currently I'm using inches. The bit I'm using is an upcut 1/4 inch end mill. Once you have the bit picked out, it brings in its RPM and other attributes, and that picks out a lot of the other variables. You just want to go through and make sure they make sense to you, because it does a fairly good job of picking the variables. Now I went through that whole process and didn't pick out my tool paths. So here I am picking out my tool paths. I do a simulation to help figure out what order the pockets are going to get cut out, and is the tool going to go through the material. Does it look halfway decent? Because you'll find sometimes when you do the simulation you find a problem that you have to redo it. I always do a side angle so I see if it's going to go through the material. Everything looks okay. Mounting on the spoiler board, I used Gorilla Tape. I find this to be pretty good. There's 2 spots there, and as soon as I touch the stock to it, it sticks. And I have a tough time getting it squared up because it sticks rather well. So I apply some pressure, and it looks like it's there. I also get all the dust off the table and off the stock. Now I've turned the sound off on the table because it is screechingly loud and would not allow you to hear me over it. So I found that I have to just silence the audio from the camera. I'm really pleased with the diameter of the circles. These circles, or these holes, are far better than I could drill with a drill press and a drill bit. You know, the wall, the character of the side wall is just fantastic. The boring tool does a very good job of making pretty side walls. Yes, the upcut end mill does tend to put some fibers straight up, but those are easy to take down with a sander. But I'm starting to see a problem. If the hole is significantly more than 2 tool diameters, you'll get a post in the center. And that became evident about here, but it looks like it took care of itself. These holes are roughly 0.74 inches in diameter. These holes are something like 1.4 inches in diameter. Now let me measure. Yes, 1.4. I'm noticing it's leaving a lot of material in the center, so I'm starting to come up with a plan as how to remove that material. And if I don't turn the machine off and I don't re-zero the axes, the bit will know exactly where, or the machine will know exactly where these posts are. Beautiful round holes. Okay, I went back into Fusion 360 and I'm coming up with a new tool path. My experience with Fusion 360 is that I take 2 steps forward and 1 step back, and you'll see that here. I can also talk about climb versus conventional milling. There's a checkbox for doing climb or conventional milling. If you think of the clockwise rotating bit, on the left side you're working against the rotation on the edge of the material, and on the right side you're working with the rotation. If you're going with the rotation, it's called climb milling, and if you're going against the rotation, it's called conventional milling. And conventional milling appears to have the best finish. Now, if you look at the lower left corner, you can see the y-axis moving back and forth and the gear mechanism that is moving it. And you can see just how gentle and smooth the rotation is. It's just cleaning up the floor and then it's done. And I check to fit, see how things fit. This is the redwood, and I'm noticing that my camera is not picking up the red character of the wood. I'm going to work on my lighting. But this is a 1/4 inch end mill, same upcut end mill, and I'm making a hole that is just slightly larger, like 0.3 or something like that. But it makes quick work of the holes. I think I made these 0.6 inches deep. Next, I had this 1/8 inch end mill I got in a batch of bits from Amazon. It says made in China. So I made a little diagram so I could describe it to the CAD program. Used a magnifying glass and counted 11 flutes on it. 0.6 inch in length, so it ought to be good for a 0.6 inch hole. And I'm really quite pleased with how this thing makes a 0.2 inch hole. Then the next bit I was using, and I put this in to show there's the difference between the two bits. And the next bit I have is a 1/2 inch down cut. Actually, I have a 1/2 inch up cut. I think I used a diagram from a different bit, but it's very similar. And these were 0.6 inch holes or 0.55 inch holes. And I'm starting to see a problem. Man, it's going deep. Dang it. This is the finished product. This is something anybody with a CNC machine could use. I use feed and wax, beeswax with orange oil. I use Gorilla mounting tape and the white side end mill. I use Autodesk Fusion 360, ArcSoft, Mach 3, and my video editing software is VSDC. My routing machine is a CNC Router Parts Pro 4896. produced by Acumenor, edited by Noel Patonsu. Please go see my website, smokelesschimney.com. Thank you very much for watching.